Hello, I'm Andrew Smith from the Open University Cisco Academy team, and we now start on switching, routing and wireless essentials for TM257. Obviously these videos are being shared as an informal resource and are also being shared with our wider Cisco Academy community. So most of you will have now completed CCNA Introduction to Networks. So you will discover that some of these slides and some of this presentation, some of the future presentation, go over stuff that you've already done. Cisco have a model of repetition, reinforcement, or operant conditioning, which is the technical term, which is not a bad thing. Sometimes it's about reminder, sometimes it's understanding. It's been a while since you may have done it. Telling you again is not necessarily a bad thing. As is my way of delivery, I'm not going to read through the slides. I'm going to talk about the slides and talk to the slides and talk you through this. There's a lot of commands in this slide deck for the first module, but there's a lot of packet tracer activities that you can do as well to go back, remember, recall, and re-engage with some of the technology being discussed, but we're actually going to focus now on switches. So in ITN, there is a very brief introduction to routers and other technologies, but now we're going to explore switches, we're going to explore wireless, and we're going to explore some other features of routers as well. You will discover some of these slides are quite wordy in this slide deck, and it's explaining how you may experience or how you may work with a live switch. Now you're thinking, well, no, I'm using packet tracer, I don't need to do that. Well, if you're a TM257 student, you are going to get hands-on with a switch. You're going to get hands-on in our day school or remote hands-on using our alternate learning experience NetLab. You do need to actually understand that the switch goes through this power up sequence. So it will obviously go for a self-test, load the bootloader software, then carry out a low-level CPU utilization, set up the memory registers, how the memory is found, then it will initialize the flash file system, and then finally load your configs if you've saved them to memory, saved them from, copy from run to start, as we would say, so running config to startup config. It's important you need to know that because in Flash you have databases like vlan.dat and other things that you may have to manage in the future, and sometimes you have to go into ROM-mon mode to do password recovery. And it's important to set up the boot system so we can actually boot which operating system we want. And yeah, there are different examples of Cisco IOSs out there. It's worth a Google because sometimes people say, well, it's not working. Well, have you got the right OS? Have you got the right image installed? Have you gone to the right TFTP server and installed that .bin, that binary file, which is the iOS operating system, and will it work on your device, whether it's a switch or a router? So it might seem quite sort of obvious, but it's not obvious, and people forget that basically a switch and a router is a computer. It's a dedicated computer that its job is to shove packets at very high speed, or shove frames at very high speed through interfaces. So you'll see there are initial startup files like config.txt, and some of you who are old enough or as young enough as me will remember autoexec.bat and config.sys, amongst other things. And the principles are still there, and you have to know what's in the boot system and where these commands and the operating system images are, and you will be tested on this in certification. You don't need to often do this, but it's often when you're doing installation, often when you're doing these critical system updates, and often when you're doing maintenance and you're there in the server room with the console port trying to do a remote install of a image. And on the front of a switch, it's all on the front, not on the back of a switch. You know, you are going to have these exciting little flashing lights. Okay, I'm not going to read through everything, but obviously, the power on light is probably the most important. You know, is it a layer 0 problem? Have you got power? Okay, have you got redundant power? Which port is it going to run? Because, you know, port status mode, are you running switching? Are you running as a layer 3 router? Is it running a duplex? It's have you set up the right speed? And is it going to allow you to do power over Ethernet, which will run the power for VoIP telephones and stuff like that? And yeah, this table goes through a sort of various combination of what all of those lights do when they're flashing, and what colours they are. I'm not going to read through this. You can actually read through this in the curriculum. But it is quite important to understand, yeah, what these mean, what the communications speeds are, whether it's half duplex, one way or the other way, full duplex, and also now, have you got too many devices consuming the power? Because obviously the switches have as the power source and then sending out 48 volt max power services to various phones or other PoE devices, because wireless access points also rely on PoE as well across the system. So have you overloaded it? Have you plugged in too many devices? Or is there a fault on the device, the remote device that is using the power Ethernet? So it's worth reading this. It's not worth memorizing it, but it is worth understanding what it means. And when you're recovering from a system crash, this tells you what you need to do. And it is very rare. I mean, rare, it's so incredibly rare, but these things do happen. And there is a power cycle resequencing process. Now, I read this, I've taught this for many years. How many system crashes have I seen on a Cisco switch? On a scale of 1 to 0, it's very much 0. So I have to simulate it with my students when I used to teach in a classroom. And it's just quite important that you're aware of this and you know these steps and you've read it in the Cisco curriculum, because you will be picked up on it in a test. In that eventuality, just in case that it happens, and you're going to have to Google it to remind yourself what it is you needed to do anyway. Okay. But what is quite important is we do actually have a thing called a switch virtual interface, or an SVI, and that means then that you can actually configure it as if it is a device, and that way then you can actually remote into it. So you can either go in via the console port, or you can remote into the switch via somewhere else on the network via a router or something like that. But SVI is a virtual interface, a virtual remote port. You can actually have the physical console port that you plug in and can configure using a terminal emulator like PuTTY or TerraTerm. But what we do is we actually set it up. The default was always VLAN 1. Historically, that is the way it was done. Nowadays, Cisco advise do any other one but VLAN 1. In these examples, they like to use VLAN 99. You can pick any number you want. So basically, you'll set up a management interface. And it's as easy as this. You can set up the config term, you set up the interface as a VLAN, and you'll learn more that VLANs are actual virtual interfaces as well that aggregate interfaces or switch ports within itself, and you can then give it a IP address. So to give a switch port an IP address, you've got to turn it off, which makes it a routing port. So the trick is you make the VLAN I give that an IP address, but that could be an IP address of an aggregate of a number of several ports. And you can give it an IPv4 and IPv6 address, and then you bring it up. Shut down it. So you can shut down VLANs as well, virtual local area networks. Obviously N, and then copy run star or WR. I mean, I've shown you all WR, the shortcut. Cisco don't teach it, it's legacy. They haven't ever gotten rid of the command because people like me like it so much. Okay. And then that way you then set up the default gateway, which you did learn about in Introduction to Networks, in some of the latter chapters. You set up the default gateway, and that way then it will then be able to talk to a router, and then it is remotely configurable. Like a router, you can do a show IP interface brief, output omitted because actually it lists all the interfaces as well. But a show IP interface brief on a switch will show both interfaces, physical interfaces, and virtual VLAN, virtual local area network interfaces as well. And that way you can actually go through and see all of them. But it will be a long output. A typical Cisco switch will have 24 ports and the ability to do hundreds of different VLANs within its configuration. So you will have to sometimes filter the port. And it's correct, it doesn't allow the routing of layer 3 packets because you've got to set other things up on the device to do that. You've actually got to set up switch ports and you've got to set up IP routing amongst other services. So it is a virtual LAN and it is a remote access, not a routing interface. So my advice, do that basic switch configuration lab within Packet Tracer. It will show you what you need to do and gain your level of experience that you require. Configuring switch ports is quite important. Full duplex means that you've got that two-way communication and it's efficient. And what we do is we actually micro-segment our LAN. So every port is actually technically a micro-segmented LAN. Each one is actually a bridge. If you know anything about old school networking and network bridges, each port is a bridge. And actually a switch is a multi-port bridge. Do we teach bridges anymore? Not really. It's useful to know the principle. Like we know that hubs were broadcast based, and and what went in one port was propagated out of everything. And then switches came along. What goes in one port is only sent to the destination port based on a MAC address. Here we now have this micro segmentation, and we have multi-port bridges. And with full duplex, you can have it both directions. Half duplex is unidirectional, one other. You can't actually have it both ways, and that's why it results in collisions. But full duplex requires two different cables, It uses two different cables on the unshielded twisted pair 8-pair cabling system, so it's transmitted that way. Okay, but different standards now require full duplex because obviously, to get those speeds, you've got to be able to have the upstream and the downstream all transmitting efficiently, and that way then the network interface card, some of the default behaviors of a legacy NIC is disabled, so that you actually have to have a network interface card that's capable of full duplex communication. So it's a bit legacy because nowadays I like to see if you could find a new network card that cannot do that. But then we do still have legacy systems out there. You need to be aware that sometimes the legacy technologies come along in your day-to-day working environment, and that way you then got to be able to work with it. And we can set the duplex, we can set the speed of a port, and obviously copper has certain behaviors and limitations, and certain ports like gigabit Ethernet interface ports will behave at different speeds than fast Ethernet ports, and you need to be aware of what those speeds are on the device. But the speed is auto, it will auto negotiate, it will always go to the best speed, which means that if you've connected it to a legacy system, or you have an innate need, especially in manufacturing, for a slower speed for reliability or to work with the robotic assembly line technology, then you might have to disable auto negotiation and you might have to set the speed accordingly. Okay, obviously fiber optic ports, out in American of course, will operate at preset speed and are full duplex by default. So yeah, here is a good example of a cable connection between two switches, and you can set it duplex full, but the speed is 100. Okay, so it's 100 megabits per second, and it will work in packet tracer, albeit simulated. But nowadays we've got Auto MDIX, or Auto MIDIX as I was brought up to say. But Auto MIDIX will auto negotiate, which means that you can now put in a straight cable where once upon a time a crossover cable was required. I still put in crossover cables between switches out of tradition, but also it helps visualize the connection and the connectivity. On our day schools, our practical labs, we give out crossover cables as well. We actually tell our centres to, but that's often because we don't know what you may encounter, and the default is crossover will work, especially if you don't know if automidix is set up correctly. But it is useful to set that up because then you don't need to worry so much about the cabling, and then you've got reliability for auto negotiation and auto bandwidth configurations as well. Okay. There is a range of verification commands, some that we've already talked about, and you can actually start realizing that some of the Cisco iOS router commands are similar to the Cisco switch commands and vice versa. So that show IP interface brief or show interfaces. It's quite useful. So you've got the startup, the runout, you've got flash, you've got version, you've got history, which are all features on the router iOS, and you can show IP interfaces. But here now, depends on how a router is configured, but a switch will definitely have a MAC address table. And the MAC address table is the content addressable memory, which means that you can actually see all the devices that have actually talked to the switch, and it's then doing the bridging or the microsegmentation, the pass-through, or the cut-through, or the store and forward between devices, which was mentioned briefly in the introduction to networks, of course. Okay, forgive me, I'm going to have a sip of my coffee. Obviously, to verify configuration, you can do show IP interface brief, you can show interfaces, or you can show run. And pass through that and filter out the commands. And you can actually see what has been set up to. As I've said, the VLAN is what takes the IP address because a switch port will not do that. But you can see if a switch port is up or down. You still have to bring a switch port up in some cases, and you have to plug a cable into it as well. Okay, and you can see your show interfaces fast Ethernet 018 there. Now it's up, protocol's up because something's connected to it. So I've plugged it in, but then I've plugged something else in at the other end, and they're now actually talking to each other at layer 2. And there is power. Okay, so if there is power and they are talking to each other at layer 2, off it will go. So often I get students saying, but it's not working. And I go, well, let's check the cable, let's check the layer 1 issue, and let's check the layer 0 issue. Is there power? Okay, and if the cable and power are okay, then let's have a look. What have we done to the device to see if we've caused any problems to it as well. And yeah, access layer, we need to show the interface to see if the line is attached, if there's power problem, if there's a connection. So I have talked to this slide before actually speaking about this slide, and it is understanding, is there a physical connection? And you can also then see the type of traffic that's going through. Is there everything behaving as we would expect? Is it dropping anything? Are there collisions? Are there late collisions where something's been sent and this is on a half duplex and then something else is being sent just afterwards, especially if it's still got some multi-broadcast features. It's got all the standard sort of redundancy checks, so it's got the checksums, and it's also got the ability to handle issues with packets that are too small or frames that are too small or frames that are too big. It's very irritating because they've written here packets, but at layer 2 it's frames. At layer 3 it's packets, okay? And a frame contains packet. There is no such thing as an Ethernet packet, it's an Ethernet frame. And we do interchange this, and it does get a little bit irritating sometimes, because then you go here to the next slide and runt frames, not runt packets, runt frames, giant packets. Yeah, so I think sometimes people forget that this terminology isn't quite interchangeable. A frame is at the layer, and it's based on the medium. A packet is based on the protocol. Okay. Anyway, sorry, forgive my rant, but it's important that I correct that, because you encounter this all the time when you're reading Cisco curriculum and you're reading others and technologies, and okay, they are packetized entities, but they're very specifically frames because of the layer that it operates at. And obviously, I think there's a lot of repetition here. Collisions in half duplex. You've read about CSMACD, carrier sense multiple access collision detection. It is worth googling that and researching that. Even though there is now a lot of technologies to mitigate that, it's again something you need to be aware of. You need to be aware of why that operates, because that can still be a potential challenge in layer 2 switch-based network, and a problem that you may need to troubleshoot. I'm not going to talk through this slide. You can actually read it in the curriculum, but this is quite a logical diagram. Basically, check the power, check the cable, check the configuration. Okay. Once you've checked the power and the cable and everything seems fine, check the configuration, but don't be afraid to go back and check the cable. Remember, you always have to check at both ends. You've got two devices connected. It could be device A, or it could be switch B, or it could be either switch. So those of you that are working on our day schools, you will be working in pairs. Okay, and that means that you've got to work with your teammate, she or he, and work out, is it my end, your power, my cable end, or your cable end, or were we both tapping on the keyboard with our elbows? Who knows? So, at the end of Introduction to Networks, we talked about SSH and setting up SSH. Telnet uses port 23. You can steal the password on Telnet. It's a legacy access technology, and I was teaching people how to hack that in the 1990s using a wonderful tool called NetX-Ray. So it is capturable. It is very, very insecure. And we're not talking about emotionally either. SSH replaced that, and obviously it's more secure. It is encrypted, and yeah, it is in effect a gobbledygook. So you're not going to be able to easily decrypt that unless you're possibly a security agency. So it does depend on the version of the iOS you're using. Some older legacy versions will not support it, so you do need to be using a K9 version 15 or above. I suspect the use of the term K9, whether they're Doctor Who fans or dog fans, but it's, there are sometimes techies do sneak things into their version naming, and I forgive them. Maybe I respect them. Okay, and then it will tell here you've got a process to set it up. You need to set up an IP domain name. You need to set up the RSA. You need to set up user authentication. You need to set up the virtual terminal lines, and you need to set up version 2. But there's nice practical activities here. You're thinking, oh, this is a lot of work. Actually, it's quite straightforward, and that is more verbose than it actually needs to be to actually set up a SSH. And you can set up the SSH to work with a virtual terminal application like PuTTY or TerraTerm, and you set it up on the SVI so that you can then work and connect into the SVI, whichever VLAN it is, and then remotely log in to SSH and verify that it's operational. And we'll be asking you on one of our day schools to actually set up SSH as one of the final steps. So we highly recommend that you carry out the practice activity here in Packet Tracer to actually set up and configure SSH. Now there's a little bit of repetition. It's important because often what happens is people do introduction to networks and then there's an academic semester break before they start on SRWE. At the OU, our timing is such that you kind of finish ITN around Christmas. You get into a Christmas mince pie and turkey haze, and then once you've come out of that haze, and for some of you, you also have to celebrate Hogmanay, you come back and you have to remember everything again. That is quite alright. And Cisco, as I say, like to repeat a little bit. We've covered in the past setting up basic router security and password settings for the privilege exec mode and for the console and for the virtual terminal. And our friends at Cisco have been for 25 years using the classic class and Cisco, and we're not going to reinvent any wheels immediately. Okay. You can also set up a banner message which just gives a legal or useful information of go away, leave us alone, or who we are here, this router belongs to Andrew, that kind of stuff. Okay. And you do copy run start, same as you do on a switch, but I've told a lot of you already that you can use WR, write, or the old write memory command. And the switches and routers will use the same types of interfaces, so you will actually have the fast Ethernet or the gigabit Ethernet interfaces on a router. Routers tend to have faster interfaces because they're the bottleneck. You might have a whole array of switches, a whole mesh network of switches all talking to each other. Then you're doing router on a stick straight to a router. Whereas the low bandwidth is going to be on the connection to the router. Therefore, it usually has a higher end gigabit Ethernet interface that is able to do full duplex. It's nice to see in this topology an old lightning strike serial cable that we don't teach anymore, but you can go and Google how to set them up. It's wonderful. You can set up bit rate and clocking and all sorts of things on them. And routers by default should only have one IP address, well, one IPv6 and one IPv4, but we can set up sub interfaces. Now, we'll cover that in a later module on this course, but yeah, we can have an interface with multiple IP addresses by having sub interfaces. So you can see an example here, and you can even see the classic interface serial 000, which must be the DTE because it's got no clock rate on it, and you have to look at what the data terminal rather than data circuit equipment is as well. But you can see IP address, a description which is useful, and then no shutdown to switch it on. Okay, so switch ports come up because you plug them in with power, or they're switched on if they've got switch port mode turned off. But then you can also, with a router, even if you plug in the cable, it won't come up until you bring it up because it must be configured. But you can no shutdown, aka router interface, without a IP address, and there is on live Cisco routers, you can do a no shutdown and a no keep alive command and bring up an interface if there is nothing plugged into it. Go and Google that. We used to do that on our day schools years ago and bring up an interface on one of our devices, even though there was nothing plugged into it. So yeah, that's a deep dark secret. But yeah, do a no keep alive on a live router, on an interface, on a router that is up. You can do a no shut, no keep alive, and it will bring it up. And then you can apply an IP address and route from it if that's what you want to do. But what is also very useful, and I have mentioned this, is something called a loopback interface. I mentioned this in ITN, and you can set these up as pseudo interfaces with IP addresses, which gives us extra networks to propagate in a small infrastructure. They are used not just as simulations, they're not used just as the makeup networks, they're actually used as identifiers. Certain protocols like OSPF, you can actually use it as a router identifier and as a way of making sure that a router has precedence in an election process. But here they're correct. They use it to simulate connections to the internet or simulate additional networks out there and give us some other interesting IP addresses within our routing tables. So another packet tracer activity for you to carry out and get used to, again, IPv4 and v6 addressing and verification of connectivity. A little bit of repetition, but good repetition to ensure that you're developing and maintaining those skills. And because of that, you've got the show IP interface brief commands, the show running config interface. You can actually then show running config of different sub parts of the running config output, and you can do a show IP route or IPv6 route as well, and see if there's local, connected, or routing protocol learned command, outputs within there with things that they've gone and learned across the system. Obviously, you can then see if it's a unicast, link local, or multicast address for an IPv6. I'm whistling through this a little bit because I'm just mindful that this is actually repetition of previous content. So it will tell you what kind of interface it is, whether it's a multicast based on the hextet and so on. And so on. But you can always do a show run, and as I say, you can actually look at the output. But you can tab through, you can look at the output. It's when the output becomes very big and verbose. These ways enable you to find the exact bit that you want if you need to. Okay? And the same with the IP route, it will show you exactly what you need. You can actually look at specific routing entries for specific networks as well on the IP route. And obviously there's nothing there to say if there are other protocols. And you can see they've deleted some of the codes. I mean, the chances of you seeing BGP at this stage are very remote, and I hope you never see RIP again, but you'll see static, you'll see OSPF, and we do deliberately in TM357 force you to learn a little bit about EIGRP as well, to prepare you for CCNP, prepare you for certification, and prepare you for reality. But connected means that we've learnt, so you've got the link, the port, but connected is, I know the network is up locally, and that's quite different and something you should be aware of. With your show commands, you can filter the output, and there is the pipe character that I've highlighted there. Because again, if you just do show interfaces, that is a very verbose output, but you can pipe to then set up a range of filtering parameters as well. It's kind of similar to regex, but not, but you can say what it will or won't include as part of the history. And we've got the command history, or the up and down arrows. And that way, I do that a lot. I type in a command, hit enter a couple of times, edit the command, hit enter a couple of times, edit the command, enter a couple of times, edit the command. What you will also learn is you can copy and paste commands from Notepad, text file, documents into routers and packet tracer as well, which is also quite useful. So you can edit offline, be in the right mode, and then just push all the commands in. So finally, and it is almost finally, do the packet tracer activities, verifying correct connected networks, and do the implement a small network practical activity as well. There's a lot of practicals here in this module that are there for a reminder, reinforcement, and just skills development as well. And I would highly commend that you do all of them. So thank you very much for listening to me for the last 35 minutes. I'm Andrew Smith from the Open University. This is for our TM257 students, but other students elsewhere, especially our instructor trainees, can use this content as well. Obviously, the TM257 references are irrelevant as far as you are concerned. Goodbye.